In this video, we're going to talk about increasing and decreasing intervals, positive and negative intervals, and end behavior of polynomial functions. Example 1. Determine when p of x is increasing or decreasing and when p has a positive or negative interval. So let's first try to make sense of this idea of increasing or decreasing. So when we're talking about increasing and decreasing, we're talking about our maxes and mins. When we're talking about positive and negative intervals, we're dealing with our zeros. So let's graph this and try to make sense of this. So we're going to use Desmos. So we're going to type in our function. We have x plus 2, 2x minus 3, and x minus 4. So now we have our function typed in. Let's just make it a little bit bigger. And let's just zoom out just a tad so we can see it. So now we want our zeros, our maxes. We have another 0, a min, and another 0. So let's just click on those again. So let's start with the increasing interval. So we look at the graph. We start by increasing. We increase towards this max at negative 0.573. We want just the x coordinate. So let's write down increasing. So we're increasing from negative infinity to negative 0.573. Now let's do our decreasing. Well, let's leave some space. We might increase again. So now we go from increasing to decreasing. So we trace the graph. We decrease from negative 0.573 to this min at 2.907. So that'd be from negative 0.573 to 2.907. All we're using is our x coordinates. So we go from increasing to the max, decreasing to our min, and then we increase again from 2.9073 to infinity. 2.907 to positive infinity. So we've handled our increasing and our decreasing intervals, and just using our maxes and mins. So we can spell out the max was at negative 0.573, and our min was at 2.907. Now our zeros, let's just spell those out. We have negative 2, negative 1.5, and 4. So our zeros are x equals negative 2, 1.5, and positive 4. So now we're going to handle our positive and negative intervals. So we're positive when the graph's above the x-axis. We're negative when we're below the x-axis. So let's take a look at the graph. Let's just make the graph a little bit bigger. So we start below the x-axis. So from negative infinity to negative 2, we're below the x-axis. That's a negative interval. So it's going to be negative infinity to negative 2. And then we go to a positive interval from negative 2 to the next 0. So negative 2 to 1.5, we're on a positive end. So negative 2 to 1.5. And then we drop to decreasing. So from 1.5 or from negative. We go from 1.5 to 4, we're on a negative interval. So 1.5 to positive 4. And again, these are using our zeros. And then from 4 to positive infinity, we are positive again. So from 4 to positive infinity, we are positive in a positive interval, or above the x-axis. Our negative intervals are below the x-axis. So to reiterate, our increasing and decreasing intervals use our maxes and mins. Our positive and negative intervals use our zeros, which again were negative 2, 1.5, and 4. And we are done example 1. Example 2. Determine when p of x is increasing or decreasing and has a positive interval or a negative interval. So we're using the polynomial x to the 4th minus 5x squared plus 4. So we're going to use the same idea as last time. So let's write down our increasing and decreasing intervals and positive and negative. So first we want our maxes, we want our mins, and we want our zeros. So let's graph this function in Desmos. Clear out the old function. We have x up to the 4th power minus 5x to the 2nd power plus 4. So let's just zoom out just so we can see it. So we have a min at negative 1.581. We have another min at positive 1.581. And then we have a max at 0. Let's write down, so let's start with our increasing and decreasing intervals. So we start by decreasing from negative infinity to negative 1.581. So negative infinity to negative 1.581. So once we had our min, we start increasing from negative 1.581 to 0. So again, we're just using our maxes and mins. Then we start decreasing from 0 to positive 1.581. So 0 to 1.581. And then we start increasing from positive 1.581 to infinity. So we've handled our increasing and decreasing intervals. Now we want our positive and negative intervals. So now we want our zeros. So we have a 0 at negative 2, negative 1, positive 1, and positive 2. So let's just write down our zeros. Negative 2, negative 1, positive 1, and positive 2. So we start positive from negative infinity to negative 2. We're above the x-axis. So negative infinity to negative 2, we're positive. And then we go negative from negative 2 to negative 1. Then from negative 1 to positive 1, we're above the x-axis. That's going to be a positive interval. So from -1 to +1. And then from +1 to +2, we switch back to negative. So from 1 to 2, we're negative. And then if we look at the graph from 2 on, we're positive. So we're going to just write from 2 to infinity, and we're done. And just to reiterate, our positive and negative intervals use our zeros, and we're analyzing whether the graph's above the x-axis or below the x-axis. Our increasing and decreasing intervals determines whether from left to right is the graph going up or down, and it's using our maxes or mins. And we are done example 2. In example 3, we're going to take a look at end behavior. So we're asked to look at the general function y equals ax squared plus bx plus c for when a is greater than 0 and when a is less than 0. So we don't really care about the b and c value, we only care about the a value. So we've already made some sliders. So if a is greater than 0, let's see, no matter what I do, it appears like both sides of the graph are going to go up or approach positive infinity. If I change it a to a negative, both sides of the graph can go down or they're going to approach negative infinity. So let's just draw this picture. So this is when a is greater than 0 and when a is less than 0. So in notation we say if a is greater than 0, as x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches positive infinity. And this little arrow just means approaches. Now, for when a was less than 0, we just write x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches negative infinity. So this section right here is going to be consistent for every sentence we write about this. What's going to change is these f of x's. So now let's change our function to y equals ax cubed plus bx squared plus cx plus d. So let's change this to a third power, raise this to a second power, give us a cx plus d. So we're out of solder d, and all we care about is our a. So if a is positive, on the left side as x approaches negative infinity, it's going down, it's approaching negative infinity. But on the right side as it approaches positive infinity, it's going to keep going up. So let's just draw what that looks like in general. So that graph looks like that. And then if we switch it to negative, it switches directions. So on the right side, or as x approaches positive infinity, I'm going up or approaching positive infinity. On the right side as I go down, it's just going to approach negative infinity. So the other graph looks like this. So let's just write our general statements first. So we have x approaches negative infinity, so this is going to be consistent to all of them. On the left side, this means on the left side, so that's going to approach negative infinity. As x approaches positive infinity, f of x is going to approach positive infinity. Now when a is less than 0, as x approaches negative infinity, this will be on the left side, f of x is going to approach positive infinity. As x approaches positive infinity, f of x is going to approach negative infinity. So another way, something to also think about, x approaches negative infinity, this is your left side. And x approaches positive infinity, it's going to be the right side of the function. Okay, let's set up our next one. So we know we're going to have those general statements. let's write this first. X approaches negative infinity, x approaches positive infinity, x approaches negative infinity, x approaches positive infinity. So let's now change it to a fourth power polynomial and see what happens. So we're going to change this 3 to a 4, this 2 to a 3, make this to a second power, make this a dx, and we'll say plus f. So again, all we care about is this a slider. So let's first make a positive. So it looks almost like the parabola, so we'll just draw it a little bit wider. So it looks something like that. And if we make a less than 0, both sides are going down, so it looks something like that. So it still looks like the parabola a little bit. So on the right side or on the left side, as x approaches negative infinity, it's the same as the ax squared plus bx plus c. It's going to be f of x approaches positive infinity. On the right side, or as x approaches positive infinity, we can say f of x also approaches positive infinity. And when a is less than 0, or when it's upside down, we have x approaches negative infinity. We're going to say f of x approaches negative infinity. And on the right side, or as x approaches positive infinity, f of x is also going to approach negative infinity. Okay, let's look at one more situation. We have ax to the 5th plus bx to the 4th plus c x to the 3rd plus dx squared plus fx plus g. So let's change this 4 to a 5, this 3 to a 4, this 2 to a 3. We'll make this to a second power fx plus g. So again, all we care about is this a term. So if a is positive, it looks kind of like that. Looks a little bit like the quadratic. And if we change it to negative, it looks like the reverse quadratic, or reverse it looks like the reverse cubic. So let's write our general forms. We have x approaches negative infinity, x approaches positive infinity, so right and left. X approaches negative infinity, x approaches positive infinity. So this is like the cubic, so on the left, or as x approaches negative infinity, f of x is going to approach negative infinity. That's when a is greater than 0. When x approaches positive infinity, f of x is going to approach positive infinity. And when a is less than 0, it's going to be just like this cubic. So we'll say as on the left, or as x approaches negative infinity, f of x is going to approach negative infinity, or sorry, positive infinity. And then on the right, as f of x approaches positive infinity, f of x is going to approach negative infinity. So let's summarize those statements. For even degree of polynomials, if a is greater than 0, as x approaches negative infinity, f of x is going to approach positive infinity. And that should be a negative. And as x approaches positive infinity, f of x is going to approach positive infinity. And also, when for even degree polynomials, a is less than 0, so we saw that in our square, our quadratic, and our cubic quadratic functions. X approaches negative infinity, f of x is going to approach negative infinity. And as x approaches positive infinity, f of x is going to approach positive infinity. Now, for our odd degree polynomials, like our 5th, so as if a is greater than 0, we say x is greater than approaches positive infinity, f of x approaches negative infinity. And as x approaches That should be a negative infinity. And as x approaches positive infinity, f of x is going to approach positive infinity. And then the reverse for when a is less than 0. So as x approaches negative infinity, f of x is going to approach positive infinity. And as x approaches positive infinity, f of x is going to approach negative infinity. So we're done summarizing. Example 4, we're given a graph and we're asked to find the end behavior, so in part 1. So recall we just write x approaches negative infinity and x approaches positive infinity. So on the left side, we're going up, so we're just going to write f of x approaches positive infinity. On the right side, we're going down, so we're just write f of x approaches negative infinity, and we're done. Part 2, consider the monomial f of x equals x squared, and it says for very large positive numbers, and for very large negative numbers, what describes the best describes f of x. We're just wanting the end behavior. So we're going to say x approaches negative infinity. We know if this is an even, so we're going to say f of x approaches positive infinity. So we're just looking at this even number here. So as x approaches positive infinity, f of x approaches positive infinity, and we're done. Part 3, a is less than 0, so it's going to just be the reverse. So it's answering the same question, just the end behavior. So x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches negative infinity, and we're done. Part 4, consider the monomial h of x equals x cubed, and we're doing the same thing, just find the end behavior. So remember the graph looks something like this. So we're going to say x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity, and we're done. Part 5, consider the monomial h of x equals negative 2x cubed. So the graph should look something like this. So we're going to say x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x is going to approach negative infinity, and we're done. Part 6, we have 8x cubed, so the graph's going to look something like this. So we have x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x is going to approach positive infinity. Number 7, we have the function 8x to the 5th minus 7x squared plus 10x minus 1, so the graph's going to look something like this. So we have x approaches negative infinity, f of x is going to approach negative infinity. As x approaches positive infinity, f of x is going to approach positive infinity. And our last one, we have g of x equals negative 6x to the 4th plus 8x cubed plus 4x squared. So that's going to be an upside down graph. So we're going to have x approaches negative infinity, f of x is going to approach negative infinity. As x approaches positive infinity, f of x is going to approach negative infinity, and we're done. We're just using our rules from that we developed above. I hope this helps you understand increasing and decreasing intervals, positive and negative intervals, and end behavior.